Look up if you dare. Gaze upon the source of all that we know. On most days, if the clouds permit, you'll see it, a brilliant orb dominating the sky, a constant presence, a familiar friend, our sun, the giver of life, the heart of our solar system. It rises faithfully each morning, painting the sky with vibrant colors, and it sets each evening, casting long shadows as it bids us goodnight. It warms our skin with its gentle rays and gives us the light we need to see, to grow, to thrive. We rarely think about its profound influence, taking it for granted as it shines upon us, but it's undeniably the single most important object in our sky. The reason we are here. Without it, Earth would be a frozen, lifeless rock, a desolate wasteland drifting through the cold void of space, a world without hope. But the sun is far more than just a gentle provider of warmth and light. It is a complex and dynamic force. It's a churning, violent nuclear furnace, a cosmic cauldron of unimaginable power. The warmth we feel, the light we see, is merely the byproduct of titanic explosions, of nuclear fusion on a scale that defies comprehension. These cataclysmic events are constantly happening 93 million miles away, a testament to the sheer power of our star. Our star has moods, cycles of activity that ebb and flow over time. It can unleash torrents of energy and radiation, powerful solar storms that could cripple our modern civilization, plunging us into darkness. This is the paradox of our sun, the duality that defines its very essence. Both creator and potential destroyer, a source of life and a harbinger of chaos. We live in a delicate balance within the Goldilocks zone, that narrow band of space where conditions are just right, where liquid water can exist, and where life can flourish in all its vibrant forms. But this gift comes with a condition, an unspoken agreement with the cosmos. We must coexist with the star's volatile nature, accepting the inherent risks that come with living in its embrace. Like villagers at the foot of a volcano, we are both blessed and threatened by the same powerful force. We benefit from its power, drawing sustenance and energy from its fiery heart, but we must also respect its dangers, remaining ever vigilant. So, let's embark on a journey to understand this celestial powerhouse, to unravel its mysteries and appreciate its complexities. We'll explore its brilliant heart, the core where nuclear fusion forges the elements that make up our world, and its stormy surface, a roiling sea of plasma and magnetic fields, where solar flares and coronal mass ejections are born. We'll celebrate its life-giving grace, the energy that fuels our planet and sustains all living things, and confront its destructive potential, the threat of solar storms that could disrupt our technology and endanger our way of life. To truly know our place in the vast expanse of the universe, we must first understand the star that made it all possible, the star that shines upon us each and every day. The sun is not just a source of light, a beacon in the darkness, and warmth, a comforting presence on a cold planet, but a complex, dynamic, and sometimes terrifying object, a force of nature that demands our respect and attention. Understanding the sun is, in a very real way, understanding ourselves, our origins, and our destiny. Our story is inextricably bound to its story, our fate intertwined with its fate. Every sunrise is a reminder of this cosmic partnership, a daily affirmation of the bond that connects us to the star that sustains us. The sun's power shapes our world, and our future, influencing our climate, our technology, and our very existence. Let's look our sun in the eye and see it for what it truly is, a source of wonder, a source of danger, and a source of life. Because to understand the sun is to understand life itself, to grasp the delicate balance that allows us to thrive in this vast and unforgiving universe. So, what exactly is the sun? What is this celestial body that dominates our sky and dictates the rhythm of life on Earth? In simple terms, it's a star, a rather average yellow dwarf if we're being scientifically precise. But let's be clear, it's far from average to us, it's ours, the source of nearly all the energy that sustains our planet. Imagine something so massive you could fit 1,000,000 Earths inside it. Think about that for a moment. 1,000,000 of our entire world, swallowed up by a single star. That's the sun, a truly staggering amount of matter, bound together by its own gravity. It holds 99.8% of all the mass in our solar system. It's the undisputed heavyweight champion, dwarfing everything else that orbits it. Unlike Earth with its solid ground beneath our feet, the sun isn't solid. There's no surface to stand on, no crust, no mantle. It's a gigantic sphere of superheated gas, mostly hydrogen and helium, elements that are quite common in the universe. In a state called plasma, this is matter so hot that electrons have been stripped away from their atoms, creating a sea of charged particles. The surface or photosphere sizzles at about 10,000 degrees Fahrenheit. That's hot enough to vaporize any material known to humankind in an instant. But that's just the surface. The temperature only climbs as you delve deeper. Deeper inside, pressure and temperature skyrocket, creating the conditions for its incredible power. It's a realm of unimaginable forces. The sun's gravity is so immense it crushes hydrogen atoms together in the core, forcing them to overcome their natural repulsion, fueling nuclear reactions. This process, known as nuclear fusion, releases tremendous amounts of energy. The sun exists in a constant balance, a delicate equilibrium, the outward push of nuclear explosions versus the inward pull of gravity. If either force were to significantly outweigh the other, the sun would either explode or collapse. And it's not static. The sun rotates, a slow, majestic spin. Its equator spins faster than its poles, twisting its magnetic fields into complex and ever-changing patterns. This tangled magnetism creates sunspots, solar flares, and other powerful events, unleashing vast amounts of energy into space. The sun is a dynamic, turbulent body, a constantly churning ocean of plasma. A cosmic ballet of gravity, plasma, and magnetism. These forces interact in ways we are only beginning to understand. Its restless energy shapes everything in our solar system, influencing the atmospheres of planets and driving space weather. Our star is alive with motion, power, and mystery. It's a source of endless fascination and scientific inquiry. And its story is just beginning. There's still so much to learn about this incredible engine that powers our world. How does the sun produce all that light and heat? The answer lies in its core. Temperatures soar to 27 million degrees Fahrenheit, and pressure is beyond imagination. Here, nuclear fusion occurs. Hydrogen atoms are smashed together to form helium. In the process, a tiny bit of mass is lost, and converted into energy, thanks to Einstein's E=mc2. Every second, the sun fuses 600 million tons of hydrogen, releasing energy equal to billions of hydrogen bombs. This energy begins a long journey outward, bouncing around for over 100,000 years before reaching the surface. Once it escapes, it takes just over 8 minutes to reach Earth. The sun's core is a relentless engine, forging the energy that powers our world. Fusion is the secret at the heart of our star. That 8-minute journey of sunlight powers nearly everything on Earth. Through photosynthesis, plants capture sunlight and turn it into food, forming the base of almost every food chain. This process also releases the oxygen we breathe. The sun drives our climate and weather, heating the equator more than the poles, creating winds and ocean currents. The tilt of Earth's axis gives us seasons, shaping the rhythms of life. Animals migrate, plants flower, and entire ecosystems respond to the sun's cycles. When you feel the sun's warmth, you're experiencing energy that began its journey in the sun's core 100,000 years ago. The sun is woven into the fabric of our planet's biology, geology, and weather. It is the silent force that makes Earth a living world. Without it, there would be no life as we know it. The sun's influence goes deep into our bodies and minds. Sunlight triggers vitamin D production essential for our health. Our internal clocks or circadian rhythms are set by sunlight regulating sleep hormones and mood. Lack of sunlight can lead to seasonal affective disorder, a type of depression. A bright day can lift our spirits, too little light can bring us down. But sunlight is a double-edged sword. Its ultraviolet rays can damage skin, causing sunburn and increasing cancer risk. We need the sun but must respect its power. Our relationship with the sun is a balance, seeking its benefits, protecting against its dangers. We are, in a sense, solar-powered beings. The sun shapes our health, our happiness, and our very biology. The sun's surface is a cauldron of magnetic activity, sometimes erupting with violent solar storms. Solar flares are intense bursts of radiation, while coronal mass ejections, CMEs, hurl billions of tons of plasma into space. When a CME hits Earth, it can compress our magnetic field, creating geomagnetic storms. These storms produce beautiful auroras, but can also disrupt power grids, satellites, and communications. Our modern world depends on technology that's vulnerable to the sun's outbursts. A powerful solar storm could trigger widespread blackouts and chaos. The sun's fury is a real, present danger. We are protected by Earth's magnetic field, but not invincible. The sun's storms remind us how fragile our civilization can be. History gives us a stark warning. In 1859, the Carrington Event, the most powerful solar storm ever recorded, struck Earth. Telegraph systems failed, sparks flew, and auroras lit up the skies as far south as Cuba and Hawaii. Operators could send messages using only the current induced by the storm. It was a dramatic demonstration of the sun's power over human technology. If a storm like that hit today, it could cripple power grids, satellites, and global communications. Our interconnected world is far more vulnerable than in 1859. A Carrington-class event would be a multi-trillion-dollar disaster, with cascading failures across society. The Carrington event wasn't a fluke, it was a warning. It's not a question of if, but when another major solar storm will strike. We must be prepared for the sun's next outburst. The sun is middle-aged, but its story has an ending. In about 5 billion years, it will run out of hydrogen fuel. The core will contract, the outer layers will expand, and the sun will become a red giant, possibly engulfing Earth. Even if Earth survives, its oceans will boil away, and life will end. The sun will shed its outer layers, creating a planetary nebula. At the center, a white dwarf will remain, a hot, dense stellar remnant. Over trillions of years it will cool and fade into a black dwarf. The sun's life cycle is a reminder, nothing in the universe lasts forever. Our world has an expiration date, written in the stars. But for now, we live in the sun's golden age. Here we are, suspended in the vastness of space, orbiting a middle-aged star, a celestial body that dictates so much of our existence. We find ourselves in a quiet corner of the galaxy, a seemingly unremarkable location that is, in reality, teeming with life. The sun gives us warmth, a comforting embrace that allows liquid water to exist on our planet, light, the very essence of visibility and the driver of countless biological processes, food and air, the building blocks of life, all synthesized through the power of photosynthesis, everything we need to exist, a delicate balance sustained by this stellar powerhouse. But it's also wild and unpredictable, a dynamic force constantly shifting and evolving, capable of storms that could shatter our civilization, unleashing immense energy that could cripple our technology and disrupt our way of life. Understanding and respecting the sun, its power and its potential dangers, is essential for our survival, ensuring we can mitigate the risks and harness its benefits. Its life cycle reminds us that nothing is permanent. Everything changes, evolves, and eventually fades away. Stars are born, from swirling clouds of gas and dust, live, burning brightly for eons, and die, sometimes in spectacular supernova explosions. Our existence is precious, a fleeting spark in the grand cosmic timeline, a fleeting moment, a brief window of opportunity to experience the wonders of the universe, of warmth and light, a gift from our star. We are living in the golden age of our solar system, a time of relative stability and abundance. The sun is both cradle and grave, the source of all that we know, source of life, the engine that drives our planet's ecosystems and harbinger of destruction, a reminder of the impermanence of all things. Our challenge is to harness its power, to tap into its boundless energy, protect ourselves from its volatile outbursts, and appreciate our cosmic story, our place in the grand tapestry of the universe. We are stardust, the remnants of long-dead stars animated by sunlight, brought to life by the energy of our star, able to look up and understand, to contemplate our origins and our destiny, the furnace that forged us, the heart of our solar system. Every sunrise is a gift, a new beginning, a reminder of our connection to the cosmos, a symbol of hope and renewal. The sun's story is our story, inextricably linked, and that perhaps in all its complexity and wonder, is the most amazing thing of all.